Hello, hello. It is another nostalgic mathematical ramble. We are looking still at IEB May 2023 paper 2. And this looks like a circle geometry question. So let's get into it. In the diagram, triangle ABC is drawn with A. So these are the vertices. A has coordinates -2 and -1. B has coordinates -10 and 3. And we don't know the coordinates of C, I think. Right. Then we're told D, the point D, -4 and 5, is the center of the circle. Okay, the circle that's been drawn. Right. ADC cuts the circle at F such that AF is equal to FD, so they've marked that for us. E is a point on the circle so that CE is a tangent to the circle at E. And we're told that BC is perpendicular to AB. So we've got ABC is a right angle triangle. Right. Whew, what a mouthful. Determine the equation of the circle with center D. Oh, I have no idea. Right, okay, so we know the center of the circle, which is fantastic. What we don't know is the radius, the length of the radius, right? So remember, for the equation of a circle is gonna look something like this. Right. So we already know the center of the circle, so we know that, okay, this particular circle's equation is x plus 4 squared plus y minus 5 squared, and then what we don't know is the value of r. So let's see if we can use the information we've been given to figure that out. Well, okay. Okay, not as scary as I thought. So what immediately, well, clearly not immediately, but what jumps out at me is, okay, this is a radius, right, DF, and we've been given information about DF. We've been told that DF is the same length as FA, and we know the coordinates of D and A, so we can work out the length of DA, and then we know that DF and FA are half of that length. Okay, so let's do that. So we're going to work out the length of AD, right, using our distance formula. So that's going to be 5 minus 1 squared plus, why did I start at the y coordinates? That's so interesting. Anyway, -4 minus -2 squared. All right, so the difference between the y coordinates squared plus the difference between the x coordinates squared, and we can use a calculator for this. However, I don't want to. 5 minus -1 is 6 squared, and -4 plus 2 gives us -2. And so that ends up being 36 plus 4, which is the square root of 40, which is the same as 2 root 10. Okay, so I'm going to move this calculation out of... Oh, I can't do it. It will not let me. Oh, there's a calculator. Okay, annoying. Right, let's see. Will you permit? Okay, I'm just going to move this as far down as I can, and you can get a sneak peek of what's coming up. So we have AD is equal to that, which is equal to that, which is equal to that. We have a random y that came along. right? So we ended up with AD is equal to 2 root 10 units long, right? And we need to bring back the y over there. Okay, cool. So since we know that this whole thing is 2 root 10, therefore df is equal to half of 2 root 10, which is equal to root 10 units. Right, so the equation in full will be x plus 4 squared plus y minus 5 squared is equal to root 10 squared. Okay, right, and that is x plus 4 squared plus y minus 5 squared is equal to 10. Okay, memo, do we agree so far? Yes, we do. Perfecto. Onward and upward. The next question says, determine the coordinates of C. So, I mean, C is part of the tangent, right, EC. And I feel like there's better hope of me finding the value of C, the coordinates of C that way. The other line that it's a part of is this line, of which we've got a lot of information on this side of the line, but we don't have a lot of information on that side of the line. So we don't know if this line is shorter than this line or they're the same length. We don't know. So we probably won't get very far with that. Then C is also part of this triangle, right? So, you know, I am like, I was tempted to see if there's a way that we can get the coordinates of C using something about this triangle. But I feel like I'd have to know some lengths, maybe the length of this, I don't know. You know, if we could use gradients, right? But we'd have to know at least one of the coordinates here to know how many rises and runs to do. What else? Yeah. So I feel like our best hope is with this tangent over here. I feel like we can get somewhere. Or maybe a combination of things. Who knows? Yeah, all being said, I'm still confused. Let's see. Okay, well, so what we do know, let's just fill in what we know. Let's start with what you know. So we know that, okay, because that's a tangent, we know that, oh my gosh, we know that this is a right angle, right, because of tan rad. Okay, so that might be helpful. Who knows? Nobody knows. Wow, ba, 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 da, 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 da. Okay, actually, I think there's a combination of things, right? So I'm feeling like I could potentially, maybe, oh, can I get the coordinates of E? I don't know, because if I could get the coordinates of E, then I could get the equation of this line because of that perpendicular relationship. Then I know the gradient, and then using the point E, I can find the y-intercept. And then if I know the equation of this line, I can also easily work out the equation of this line because I've got the 2 points D and A on it. So then I can find the point of intersection, and then I will have found C. Um, hmm. Is this a simultaneous equations thing? Oh, the confusion is real. The confusion is real. The confusion is real. Is real. The confusion is very real. Okay, you know what? Let me just work out gradients just for yes. So the gradient of AB is 3 minus 1 divided by minus 10 minus 2. So this is 4, and minus 10 plus 2 is minus 8. Whoa. So that is negative a half. So then the gradient of this line would be the negative inverse of that, the negated inverse of that. So it would be positive 2, right? So this line would be equal to y is equal to 2x plus some constant. Okay, then let's look at this line. Okay, so the gradient of, that's very light, isn't it? Let's not do that. Let's not blind the babies. Let's add a darker green. Right, so the gradient of AD, and also like, how did we decide? Okay, we know that ADC is a straight line, so okay, cool. Just having a moment of paranoia. So second bullet point is what I'm referring to. Right, so we've got y, so 5 minus 1, and then the x coordinates minus 4 minus 2, which is 6 divided by minus 4 plus 2 is minus 2, which is negative 3. So, and in fact we can actually determine the equation of the line AGC, right? Because let's take it to the top. It's gonna be a nightmare to move around. Don't do that, Tommy. Ish. Okay, you saw where I was pointing, right? Right, so we know that the equation of line ADC is going to be y is equal to negative 3x plus some constant. I don't want to use C again because I've used it there. So we can sub in one of the points. Let's sub in A. So we've got negative 1 is equal to negative 3 times negative 2 plus k. So negative 1 is equal to 6 plus k. And so negative 1 minus 6 is equal to k. So k is equal to negative 7. So the equation is y is equal to negative 3x minus 7. Okay, so we now know that. Don't waste space. So this is y is equal to negative 3x minus 7. Okay. Okay. I don't know what I'm doing. I don't like this feeling, not knowing what I'm doing. Okay, anyway, done having a sob party for myself. there some angle of inclination stuff going on here? Is there? Oh, but like I can figure. Oh my gosh. Okay, so I can figure out what C is, right? Because I have a point on the line. Why confuse yourself, dummy? Why confuse yourself? Anyway, okay, let's move things around so that we can create some space. This is going to be painful as anticipated, but anyway, let's do it. Let's keep you here, comrade. Let's try. Ugh. Mistakes were made. Mistakes are always made. Maybe this much won't go. Oh, it is moving with the flowers. Am I really mad at this being here? I'm not really mad. Okay, so we are trying to figure out what this is because we know what that is. And if we can find the point of intersection between these two equations, then we have found the corners of C, right? So, okay. Sub B into equation of line BC. Okay, so we know that it's y is equal to 2x plus something. We need to find out what the something is. So that'll be 3 is equal to 2 times negative 10 plus the something. So 3 is equal to negative 20 plus c. And we can see from there that negative 20 plus 23 is equal to 3. So the c must be equal to 23. So the equation of the line BC is y is equal to 2x plus 23. The mystery is solvero. Right, let us erase that. Okay, awesome. So now we can just find the point of intersection between y is equal to 2x plus 23, and y is equal to minus 3x minus 7, right? So we can equate the two, right? 2x, for which value of x is this y value equal to that y value, right? So that's what we're trying to solve. Yup. Right, if we move things around, we end up with that, and x is equal to negative 6. So we know that, okay, these two equations produce the same y value when x is equal to negative 6. So let us find out what that y value is, in fact. Just going to, in all untidiness, cordon that bit off. Could use either equation, probably use both just to check, right? So y is equal to, let's kind of say what we're doing. When x is equal to negative 6, y is equal to 2 times negative 6 plus 23, which is negative 12 plus 23, which is 11. Right, and if you double check in the other equation, right, if we put negative 6 in here, right, this ends up being positive 18 minus 7, which is also 11. Perfecto. So it is, in fact, the point of intersection between the two lines. Right, so therefore, the coordinates of C are negative 6, which is good. We are, in fact, on this side of the x-axis, so we're expecting a negative number, and positive 11, right? again, good, because we're expecting something up here. I mean, don't get married to a diagram. You know, they do always say it's not drawn to scale, and they could be leading you down a rabbit hole. But I feel like a lot of the time, diagrams give a good indication of what's going on. So, yeah, memo agrees. Wow, that was hey, that nearly took me out, man. Wow. Okay, so let's just fill in what we know so far, which I forgot to do for the previous question, and thankfully we didn't actually need the info from the previous my back the previous question to complete it. But this is the last part of the question, and I suspect it's going to bring everything together. So we know the equation of the circle is that. We know that this is y. Oh. You know, I could just write this here and then transplant it. Okay. Firstly, make it tiny. Secondly, rotate it. So it's gone. Can I rotate this without pressing on things? There we go. Right, so we know the equation of that line. We also found the equation of another line, minus 3 minus 7. Okay, that is the equation of, where can I put this without being a distraction? Maybe we'll just make it super tiny. Right, it's not tiny enough. Okay, right, so we know that that's for that one. We also found the coordinates of C, which was minus 6 and 11. Right, so yeah, that's a good chunk of the stuff we know so far. Anyway, so the question at hand says, determine the length of the tangent CE if it is given that the coordinates of C is negative 6 and 11. Oh, okay. Getting a nice confirmation that your answer for the previous question was in fact correct. Right, so we want the length of the equation C, the line segment CE, right? Just need to revive my laptop. Okay, cool. So in order to find the length of the tangent, we need the coordinates of E. That we do. We have the coordinates of C. We need the coordinates of E. Right. Okay. I think I have an idea. So we know the gradient of this line, right? It's negative 3 from our previous calculation. So then we know the gradient of that line. And then we have a point on that line as well, which is the point D. So we can work out the equation of this line. But how will it help us find E? Well, we know the equation of the circle. So we could find the intersection of the line DE with the circle, and that would give us the coordinates of E, potentially. How's that? Am I going a long route here? It smells like it, but I am committing. Okay, so we know that MCD is equal to negative 3, right? And that's from the previous question. And therefore, MDE, the gradient of the line segment DE, will be the negated reciprocal of negative 3. So it's going to be positive and behave. Positive a third, right? So we know that the equation of the line DE is going to be y is equal to a third x plus c. Okay. Right. So then we can sub in the point D, okay, which is negative 4 and 5. So we have 5 is equal to a third of negative 4 plus c. 5 is equal to negative 4 thirds plus c, which leaves us with c is equal to 5 plus 4 thirds, which is 19 thirds, I think. Right, 5 is equal to 15 thirds. Right, so that means the equation of the line DE is y is equal to third x plus 19 over 3. So if we want the coordinates of E, we are going to need to substitute, well, solve these simultaneously, right? E lies on this circle and it also lies on this line. So we need to solve the two equations as a set of simultaneous equations. So let's see. So this is equation 1 and this is equation 2. So sub 1 into 2. So we've got x plus 4 squared plus a third x plus 19 over 3, right, replacing that y, minus 5 squared is equal to 10. Okay, and I'm going to expand, so that's going to be x squared plus 8x plus 16. Just quickly simplify this. So 19 over 3 minus 5 is just going to leave us with, so this ends up being 4 thirds. Okay, well, plus 4 thirds. Okay, so if we expand that, you know what I'm going to do? Before I expand it, I'm just going to do this. I'm going to factor out a third and just be left with x plus 4, right? Oh, this is already getting very interesting. Okay, I see opportunities for shortcuts, right? So I'm seeing an x plus 4. We had an x plus 4 over there, so I am just going to quickly undo the expansion that I did over there because there might be an opportunity for factoring out a common factor. So if I'm squaring this, right, this is like if we're saying AB squared, right? Remember that A will be squared and B will be squared, okay? So this is just the same as a third squared and x plus 4 squared, okay, right? And so these two terms have an x plus 4 squared in common, so I'm going to factor that out. Okay, and I'm going to be left over here just with a 1. Okay, and over here we're left with a third squared, which is a 9th. Right, and I'm actually going to keep this squared, right, so that because I see that this is just a number, so we're going to be left with this on the one side. We can then square root both sides and, you know, spare ourselves having to expand. Oh my goodness, I just expanded for nothing, right? So this is 10 over 9. Okay, if we then divide both sides by 10 over 9, okay, we're then going to get x plus 4 squared, and that's going to be 10 times 9 over 10, so that's just going to be 9. Oh, this is already looking so beautiful. I hate it, like when something works out so nicely and then it turns out to be wrong. Oh, that's so painful, right? So we can square root this, but remember that we'd have to consider both the positive and the negative square root here, right? So if we say the square root of x squared is equal to 9, okay, that means x could be 3 or x could also be negative 3. That would also work. So we have to consider both cases. Righty doos. And so x plus, oh, x plus 4 is equal to 3, or x plus 4 is equal to minus 3. It feels like it's time to shrink things, so let's do that. Okay. Right. Okay. Oh. Yay. Okay. Right. Okay. So either x is equal to 3 minus 4, which is negative 1, or x is equal to negative 3 minus 4, which is negative 7. Right? So just to remind ourselves where we even were, what necessitated this, we are trying to find the coordinates of E, right? And we know that E lies on, it lies on this line, DE, okay? And it also lies on the circle. So we used simultaneous equations to figure out, okay, at which points do these functions share points in common, okay? That statement did not make sense, but I hope it made sense. Okay, so pretty much we solved these simultaneously by substituting this inside here, right? So now, after all of that algebraizing, we have found that, we have found that when x is equal to negative 1 and when x is equal to negative 7, we find points that lie both on the line DE and on the circle, right? So now obviously E can't be both of those. We need to reason about which of the two x's belong to E, okay? And because we know that E is on the right of the point D, right? It's not on this side, it's on this side. So we know that the x coordinate of E must be bigger than negative 4, okay? So we would then say, let's do a different color, but the x coordinate of E is greater than the x coordinate of D. So therefore, the x coordinate of E must be, let's look at what our options are here. It can't be negative 7 because negative 7 is smaller than the x coordinate of D, which is negative 4. So it must be negative 1. Okay, so it is this guy. Okie dokie. Right? Yes. So the x coordinate of E is negative 1. And so to find the y coordinate, right, we can substitute it into either equation. The linear one is faster, right? So we sub it in there, and that gives us 6. You can verify that if you please. You should verify that. Right, very good. So we now know that the coordinates of E are negative 1 and 6. So back to our question, we need to find the length of CE. We now have the coordinates of C, we have the coordinates of E, so this is a home run, right? So let's do another color, right? Therefore, CE is going to be equal to, the y coordinate of C is 11 minus the y coordinate of E, which is 6. And then the x coordinate of C is negative 6 minus the x coordinate of E, which is negative 1. Oh, why do I keep doing that? Right. Okay, again, something you should punch into the calculator, but I am not doing it. And I don't know why. Maybe it's because that calculator and I just don't get along well. Anyway, so this is the answer that I get. Let's see what the memo says. Oh my goodness, the memo says something else. This is what I always dread. This is like my deepest, deep down dread all the time. Okay, right. So we need to figure out where I went wrong. Okay. So let us go step by step through everything that occurred. Right. So I did start by filling in a whole lot of stuff that we don't actually end up needing in the solution. Okay. I'm just going to, right. So okay. Taking a deep breath. Let's do it. So let's just make sure that I copied everything down correctly. So the equation of my circle is correct, and the equation of CA, let's just double check that that indeed is correct. So if I put in, so I'm going to bring out calculator for this. Okay, so I'm just going to check by putting in this point and this point. I'm going to put them into this equation to make sure that that equation is in fact correct. Undo. Okay, I don't know. Anyway, so let's say -3 times, I start with D, -4 minus 7. That does in fact give me 5, so that's very promising. Then we have -3 times -2 minus 7, and that gives me -1. Awesome. So I can be confident that this equation is correct for the line ADC. Okay, so now what do I want to do next? So I want to hide the calculator. This is what always happens. This is why I don't like you. This is why I don't like using your calci. Oh my goodness. I think for all the hate that I give it, it's just going to make my life hard. Anyway, okay. Right. So we know that, okay, where's my laser pointer? Maybe a less violent color. Yeah, maybe let's do a cute green. Okay, so we know that the gradient of CD is -3. We know that with confidence. And so the gradient of DE is going to be a third. Yes, I am happy with that. -3 times a third is -1. That is the relationship. Oh my goodness, that is the wrong thing. The horror and the pain. So that is just wrong. That relationship is wrong because these are not perpendicular lines. Oh my goodness, they're not perpendicular. So I can't say the gradient of this times the gradient of this is -1. Guys, imagine something working out so beautifully but based on like the completely wrong idea. Oh my goodness, I'm so embarrassed. Where did I even get my qualifications? This is just so shocking. Shocking. Okay, so this whole strategy this whole strategy was just wrong. Wrong. Okay, so what we need to do is I am just going to erase my whole life. Shoo. I'm so shook. However, you know what? There were still some valuable life lessons. We learned how to use a nifty factorizing trick to spare us doing some ugly expansions, you know. And it worked out with such nice numbers. And this is exactly what I said. I said this is what I dread. I really dread when something works out so beautifully and then it turns out it was just all wrong. You even have confidence, like working through it, eh? Like you're like, ooh, this cannot be wrong because it's too beautiful. And then it's wrong. Yeah. Haike. Haike sana, haike, 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 haike. Oh, there it is. Oh, that's the thing I wanted. The menu. Okay. Wow. Back to square one. Determine the length of the tangent CE if it is given that the coordinates of C is -6 and 11. Okay, let's put on real brains now. How are we gonna find E, huh? What you gonna do? How you gonna act? Are you gonna and all that? Are you gonna do back? So I feel like I'm just gonna erase things because there's a lot going on here. How are we gonna find it? Okay, so that is a right angle. We know that. We really know that. That is true. Right. Okay. Did you hear the news on the radio today? People have agreed to give their lives away. Okay, so I mean, one of the things that I'm thinking is, this relationship here, right? We can relate the gradients of DE and CE, which gives us one piece of information about E. If we wanted to go the simultaneous equations route, we would need another piece of information about E. I mean, technically we do have it here. But I just wonder how messy that will get. Let's see. Let's try. What else do we have? What else do we have? Okay, so if the coordinates of E are xy, right? Okay, we know that the gradient of DE will be y minus 5 divided by x minus 4, so x plus 4. And then the gradient of CE will be equal to y minus 11 divided by x minus c, so x plus c. And we know that the relationship between these is y minus 5 divided by x plus 4 times y minus 11 divided by x plus 6 is equal to -1. Okay, this already feels painful because we're going to end up with a quadratic y term and a quadratic x term, and to try and solve these two simultaneously is going to give us gray hairs. So I am going to say a bit of a no to that. But good thinking, Tammy. Good thinking. Keep trying. Right, so let's just park that somewhere. Okay, and there's a little 2 from previous failings. Let's decide that. Okay, right, back to the thinking board again. Would be nice. Oh my goodness. Oh. Okay, let me complete my train of thought. So I was just saying, it would be nice if we could use Pythagoras up in here, right? We've got a right angle triangle. I mean, wouldn't that be lovely? So in fact we can. This is a radius, so we know the length, courtesy of this guy. And this we can also work out because we know the coordinates of C. We know the coordinates of D. We can use the distance formula, and then we can use Pythagoras. I don't know, guys. I don't know. How do you feel about paper 2? Like, my goodness, paper 2 is interesting. Right, so we know that DE is equal to the square root of 10 because it's a radius. Right? And then we know that, well, we don't know what DC is, but we can work it out by using the distance formula. So we've got 5 minus 11 squared. Okay, let's just, yeah, it's in view there. That's the coordinates of C, yeah. And then plus, so we've just done the y coordinates. Let's do the x coordinates. Right, okay. And again, something that we can use the calculator for, but my soul is just so defeated, man. Okay, so -4 plus 6 is 2. Square that is 4, so that is the square root of 40. Okay, I'm not even gonna bother with simplifying that because it's going straight into Pythagoras, right? So we know that EC squared is going to be equal to the hypotenuse squared, DC squared, minus DE squared. Okay, and that's because Pythag said so. We love you, Pythag. Love you for laugh. Right, so DC squared is that squared, which is just 40. And then DE squared is root 10 times root 10, which is just 10. And that becomes 30. And therefore, EC is the square root of 30. So it's going to be square root 30 units long, which is indeed the answer on the memo. Wow. Wow. Okay, I think I need to call it a day and just reset my brain because wow.